Why can whales dive 2,000 meters with ease, but submarines can't? A submarine is essentially a hollow steel can that has to keep 1 atmosphere of pressure on the inside to keep the crew alive. The deeper it goes, the more the ocean tries to crush it. Eventually, the pressure difference becomes so immense that the steel hull implodes, turning everything inside into paste. A whale, on the other hand, doesn't fight the pressure. It cheats. Before a deep dive, a whale exhales over 90% of the air from its lungs. As it descends, the crushing pressure collapses its lungs completely. The whale essentially makes itself solid. With no internal air pockets, there's no pressure difference to crush it. It becomes one with the ocean's pressure, not a victim of it. This is the same reason humans get the bends. A scuba diver has to breathe compressed air that matches the outside water pressure, which forces nitrogen from that air to dissolve into their blood. If they come up too fast, that nitrogen forms bubbles in their veins, like opening a can of soda. But the whale, diving with empty lungs, has no air, and therefore no nitrogen to cause this problem. So, where does it get its oxygen? It doesn't store it in its lungs. It stores it directly in its muscles. A whale's muscle tissue is packed with a protein called myoglobin, turning its entire body into a massive, built-in oxygen tank. Now, this doesn't mean our technology is weak. We've built submersibles that can reach the bottom of the Mariana Trench, but you have to understand the difference in design. A military submarine is a city, designed to keep a large crew alive for months. A deep-sea submersible is a tiny, solid titanium sphere designed to do one thing: survive a short, brutal trip to the bottom. So, in the end, the submarine's limit isn't the weakness of steel, it's the fragility of the air-filled humans inside, and the incredible evolutionary genius of a creature that learned how to become solid.